Hello friends, today in this session we will discuss the solution of problems which were there in GATE 2023 examination. Generally questions in GATE are straightforward, but many a times they cover the syllabus which is not included in your UG program. And sometimes questions require application of basic theory or basic principle to arrive at the solution. So in the first part, we will discuss the questions which were asked in the forenoon session. And the first question is, G1 and G2 are the slope of the approach and departure grades of a vertical curve. G1, the absolute value of G1 is less than the absolute value of G2. That is the condition. And G1 and G2 are not equal. G1 and G2 are not equal and not zero also. That means there is a gradient. Now there are three statements made. One, plus G1 followed by plus G2 results in a sag vertical curve. What is this statement? That plus G1 followed by plus G2. Remember, G1 is smaller. So plus G2 is like this. So this is plus G1 and this is plus G2. Now what you get here? It is basically a valley curve or crest curve. So it says that statement 1 that G1 followed by G2 results in a sag vertical curve. So statement 1 is true. Second statement is minus G1 followed by minus G2. Again G2 is steeper. So minus G2 will be like this. Minus G2. It results in a vertical curve. Now statement says it results in a sag vertical curve. It is not a sag vertical curve. It is a crest. So statement 2 is not correct. Not true. And third statement is plus G1 followed by minus G2. That results in a vertical crest curve. This is vertical crest curve, summit curve. So this statement is also true. Statement 3 is also true. Now based on this statement, the question is what option among the following is true? Statement 1 and statement 3 are correct. Statement 2 is wrong. Statement 2 is wrong. Statement 1 is correct. Statement 3 is correct. So first option is correct. Statement 1 and statement 2 are correct. Statement 1 and 2 are not correct. Right? So we rule out it. Third is statement 1 is correct. Statement 2 and 3 are wrong. 3 is not wrong. So it's also ruled out. And the last statement 2 is correct. This is not correct. So it is also ruled out. So only option A is the correct answer. Question 2 in the forenoon session is, for a horizontal curve, the radius of a circular curve is obtained as 300 meter with a design speed of 15 meter per second. If the allowable jerk is 0.75 meter per second cube, what is the minimum length of the transition curve? Now, minimum length of transition curve, LM, is given by this equation. V is cube upon CR, where V is the speed in meter per second, R radius of the curve in meter, and C what is called rate of change of radial acceleration. That is called the jerk. Now here it is straightforward because V is given 15 meter per second. It is 0.75 into 300. That is 15 meter. That is the answer. The next question is a plot of speed density relationship of two roads A and B are given. Now this is a typical question. This is a typical question. Third, that there are two roads and these are their speed density correlation. A, this is what UA and UB and KA and KB. Now, question is, what is the ratio of capacity of these two roads, A and B? Now, when you have the speed density relationship, K here is density, U is speed. When you have a linear relationship between speed and density, then it is green shield model. And green shield model says that speed is free flow speed 1 minus K upon Kj. That is the equation, speed density equation using green shield theory. Green shield theory applies only when speed density relationship is linear. Now here UF is the free flow speed. When density is 0, then speed is maximum and that is called free flow speed. And when speed is 0, that is called jam density. So Ka and Kb are extreme conditions of density, they are jam density, and Ua and Ub are free flow speed on two roads. And capacity of this equation is given by 1 by 4 into free flow speed into Kj, jam density. Now jam density Ka and Kb, speed, free flow speed Va and Vb. So this is capacity of road A is 1 by 4 Ua into Ka, and capacity of road B is 1 by 4 Ub into Kb. And if you take the ratio of these two, that is Ua into Ka upon Ub into Kb. That is the answer. That is the ratio. And this answer is C. Ka into Ua upon Kb into U. That is how it is to be done. Next question is, here a table is given. On the left side of the table, there are test reporting convention, how a test report data is reported. And in the right side, you have the type of test. So reporting ratio, reported as a ratio, reported as percentage, reported in temperature, reported in length. So, and on the right side, you have the solubility of bitumen, softening point of bitumen, Los Angeles abrasion test, flash point of bitumen, ductility of bitumen, specific gravity of bitumen, and thin film oven test. Now let us see how these parameters are reported. Solubility of bitumen. The bitumen is dissolved in some solvent like carbon tetrachloride or carbon disulfide, and it should dissolve 100%. If it is not dissolving 100%, we express the solubility in percent, 99%, 98%. So solubility is in percent. Then softening point of bitumen is the temperature at which the bitumen attains a softening. So softening point is in degree centigrade. Los Angeles abrasion value is also expressed in percentage. There is a percent loss in the weight of the aggregate. Flash point and fire point, they are in degree centigrade. That is the temperature at which the bitumen will start flashing the fire. Ductility is a measure of the, when a sample of bitumen is stretched, then how much length it can gain before breaking. That is in centimeter. In centimeter. Specific gravity of any material is a ratio. It doesn't have any unit. And thin film oven test. Thin film oven test, in this we also express percent loss in bitumen after short-term aging. So this is also in percent. Now these are the test and their representation. Now P here on the left side, you see reporting is as a ratio, Q as percentage, R as temperature, and S as length. Now let us see how these are made. So P ratio is only specific gravity. So it is 6. Q percentage is 3. 1, 3 and 7. So it is 1, 3 and 7. R degree centigrade, there are 2 and 4, softening point and flash point, and S is length. Length is this one, ductility, 5. Now you see the 4 options which are given. P6 is fine. Q1 is okay. R2 is also okay. S7, no, this is not correct. So this option is not correct. Second option is P6, Q3, R4, S5. Now P6 is okay, Q3 is also okay, R4 is fine, and is also fine. So this is the correct answer, B. Then C is P6, Q1, R2 and S5. See here, P is 6, correct, Q is 1, correct, R2 is correct and is also correct. So C is also a correct option. Now D option is P6, Q3, R4 and S7. S7 is not correct. This is correct. This is also correct. This is also correct. But this is not correct. So this is not. So only B and C are the correct options given in the question. So these are 4 questions which were there in forenoon session of 2023. Another 4 questions in afternoon session. The first question is, which of the following is equal to the stopping side distance? Here 4 options are given. Braking distance required to stop plus distance traveled during perception reaction time. B, braking distance required to stop minus distance traveled during the perception reaction time. C is braking distance required to stop, and D is distance required to perception reaction time. Now, this is a very straightforward question. Stopping side distance SSD is 0.278 Vt plus V square upon 254F. This is what we call the lag distance, and this is called the braking distance. And sum of these two is the stopping distance. Now here small t is the perception reaction time, and that is why sometimes this is also called perception reaction distance, and this is the distance required to stop, because once you apply the brake, after that you need V square upon 254F. So the correct option is lag distance or perception reaction distance plus braking distance. That is option 1, option A. The second question is, as per IRC guidelines, extra widening depends upon which of the following parameters? Horizontal curve radius, super elevation, number of lanes, or longitudinal gradient. Now this is also a simple question. The extra widening as given in IRC code is given by this equation, NL square upon 2R plus V square upon 9.5 square root of R. That is the equation to calculate extra widening on horizontal curve. Now here n number of lanes, L the wheelbase, R the radius, V is the speed. It doesn't depend upon the gradient. It also does not depend upon superelevation. And therefore option B and D, B is superelevation and D is longitudinal gradient, they are not valid, and correct answer is only A and C. That is number of lanes and the radius of the curve. Third question is typical. Now here it says a figure is given and figure is like this. It presents the time space diagram for when the traffic on a highway is suddenly stopped for a certain time and then released. Which of the following statements are true? Now you look at this time distance diagram carefully. Initially the vehicles are moving in a normal speed. Suddenly it is stopped. Now the stoppage may be because of traffic signal or it may be because of some accident has occurred on the road. So vehicles are now piling up behind this point. So this portion Q which you see in this figure, that is basically when the vehicles are stopped bumper to bumper, and that is what we call the jam density. Speed is 0 here. Once the incident is cleared or traffic light turns green, then the vehicle start moving. Now when they start moving, the speed is low but flow is maximum. Flow is very high and that flow corresponds to the capacity of the road, and capacity of the road generally occurs much lower than the free flow speed. So the question is, speed is higher in region R than in region P. See region R, the speed in this figure is given by the slope of each line. And the slope of these lines in region R is much lesser than the slope of the lines in region P. And therefore to say that speed is higher in region R than in region P is not correct. So answer A is not correct. The second is volume is lower in region Q than in region P. Here is the region Q. Now in this region the vehicles are standing bumper to bumper and therefore there is no movement and as such there is no flow. So flow here is 0, density is equal to jam density. Therefore it is correct to say that volume is lower in region Q than in region P because 0 is lower than any other value and hence B is correct. Now C is volume is higher in region R than in region P. Now see here R I told you here the vehicles are moving at capacity and therefore this is the highest flow. So this volume is higher than flow in any region either P or Q. So this statement is also correct. Now the fourth statement is density is higher in region Q than in region R. Now Q is the region where vehicles are standing and that is what I told you, that jam density, and jam density is the highest density on the road and therefore this statement is also correct. So D is also correct. So these three statements B, C, D are correct. The last question is, consider the Marshall method of mix design for bituminous mix. With the increase in the bitumen content, which of the following statement is or are true? Number 1, the stability decreases initially and then increases. Now this is not correct statement because when you plot binder content versus stability, it is like this. It increases first and then reduces. So statement A is not correct. The flow increases monotonically. Yes, the flow in the mix will increase monotonically with binder content. That is like this. So B is correct. B is correct. C is air wires increase initially and then decreases. Air wires do not follow this trend that increases and decreasing. Air wires will continue reduce, and therefore C is also not correct. And D is the wires filled with bitumen increases monotonically. This is also a correct statement because in any bituminous mix, when you plot binder content versus VFB, it will increase like this. So D is also correct. So only two statements B and D are correct. So friends, thank you very much for watching this video. You can write a suggestion in the comment box.